Okay, let's dive into this. What if the moon, our moon, was suddenly heading right for us on a collision course with Earth?
Hmm.
It's a pretty dramatic what if, I know, but exploring this kind of thing really helps us get why the moon is where it is, how vital that position is.
It absolutely does. It's a thought experiment, sure, but with some really serious implications. By picturing this shift, we can really see the delicate balance of the whole Earth-Moon system.
Right. So picture this. You've got 150 days until impact. Chaos is already breaking out everywhere. Tides are just soaring.
Yeah, the gravitational effects would start escalating rapidly.
We're talking coastal cities, New York, Miami, London, places like that, just disappearing underwater,
Okay.
swamped.
It would be catastrophic flooding on an unprecedented scale.
And it gets worse, right? Because
Yeah.
it's not just the water.
No, you'd see a huge increase in volcanic activity,
Yeah.
earthquakes.
Yeah.
The ground itself would become unstable.
The Ring of Fire, I imagine, would be going absolutely nuts.
It would likely be incredibly active, yes. All because the moon's gravity is just getting stronger and closer, pulling and stressing the Earth in ways it's not used to.
It's wild because, like, a year out, T minus 365, you might barely notice.
The initial changes would be subtle, yeah. Maybe slightly higher tides, a bit more wave action on the beaches, almost imperceptible at first.
Which kind of brings us to the core question. Why is the moon being right there so darn crucial? It's not just for mood lighting, clearly.
No, not at all. It plays a huge role in stabilizing our climate, for one. And, of course, the ocean tides. Those are the big ones.
Okay, so let's rewind. T minus 365 days, the moon's still way out there, 384,000 kilometers away.
Right, so vast distance. You could theoretically fit all the other planets in our solar system into that gap between Earth and the moon.
Wow. Okay, so it has a long way to go in our scenario. And like we said, effects are small. Your beach towel might get a bit damp.
Exactly. The gravitational pull is still within, let's say, manageable limits for Earth systems at that point. But the change in trajectory is the key problem starting.
Okay, but why does it stay up there normally? It's not just floating, right?
No, it's all about gravity and motion. The moon's moving fast over a kilometer every second. That speed, its velocity, wants to fling it outwards.
But Earth's gravity pulls it in.
Precisely. Earth is much more massive, so its gravity constantly tugs the moon, keeping it in that stable orbit. It's a balance.
Got it. So Earth holds on to the moon, but what does the moon do for us besides the tides? You mentioned climate.
Yeah, climate stability is a massive one. The moon's gravity helps keep Earth tilted on its axis relatively consistently.
Our axial tilt.
Yeah, that tilt gives us our seasons.
Yeah,
Without the moon's steadying influence, that tilt could wobble dramatically over long periods.
and that would mean.
Wild climate swings, you get that, like the Sahara Desert locked in ice for ages, or Canada experiencing unbearable extreme heat. The moon helps prevent that kind of chaos.
Okay, maybe extreme Canadian heat isn't the dream. And then the tides.
The tides, yes. The moon's gravity is the main reason we have high and low tides. If it gets closer, like in our scenario, those tides go haywire.
And we'll see how haywire soon. One thing, though, you mentioned its current speed. If it was heading straight for us now, how long would it take?
Oh, incredibly fast. At its current orbital speed, if its path was directly towards us, impact would be in under 5 days.
5 days. Okay, so for our year-long thought experiment, we're assuming something slowed it down considerably.
Exactly. We need time for the effects to unfold in this hypothetical. So let's jump forward. T minus 300 days.
Okay.
The moon's now significantly closer, maybe 250,000 kilometers away.
That's a big chunk of the distance covered.
And at this range, the gravitational effects really start to bite, especially the oceans.
How so? Explain the tide thing again, but ramped up.
Okay, so the moon pulls on the Earth, but it pulls harder on the side of Earth closest to it than the side farther away. This difference in pull stretches the Earth slightly, and the water, being fluid, responds dramatically, creating bulges.
The tidal bulges. High tide.
Right. But with the moon much closer, that pull and the difference in pull is way stronger, so the bulges are much bigger.
How big are we talking at T minus 300?
We could be seeing tides rising maybe 5 meters higher than normal spring tides.
5 meters. So those cities I mentioned, New York, Miami, London, they're facing serious flooding now.
Absolutely. Mass evacuations, infrastructure crumbling roads, power grids, water systems. A massive humanitarian crisis unfolds.
And what about nature? Coastal ecosystems?
Devastated. Think about sea turtles needing specific beaches to lay eggs, or birds like pelicans nesting low down. Their habitats would be washed away.
Right.
And then there's saltwater intrusion. As the sea level rises, salt water pushes into freshwater rivers and groundwater.
Contaminating drinking water.
Exactly. A whole other layer of disaster for survivors.
This is grim. It makes you wonder, has Earth ever faced anything remotely like a massive impact? You hear about asteroids, but...
That's a really great question. And the answer, in a way, is yes. But it's tied to the moon's own origin story. We need to go way back.
How far back?
About 4.5 billion years ago, to the very early days of Earth.
Okay, primordial Earth, what was it like?
Well, the solar system was a messier place, more protoplanets flying around. And the leading theory is that one of these, an object roughly the size of Mars, scientists call it Theia, slammed into the very young Earth.
Whoa! A Mars-sized object hit us.
A truly cataclysmic collision, unimaginably violent.
What happened?
The impact would have vaporized rock, thrown massive amounts of debris into orbit around Earth. And that debris, over time, is thought to have clumped together, coalesced.
And formed the moon.
That's the prevailing theory, yes. The giant impact hypothesis. So the moon is essentially made from bits of early Earth and bits of Theia fused together after this colossal impact.
That's incredible. So a giant cosmic smash-up gave us our moon. How confident are we about this? What's the evidence?
It's pretty strong. A key piece comes from the moon rocks brought back by the Apollo missions.
Right, the astronauts collected samples.
And when scientists analyzed those rocks, their composition, their isotopes, were remarkably similar, sometimes almost identical to rocks found here on Earth, much more similar than you'd expect if the moon formed somewhere else entirely.
Suggesting they came from the same original material?
Exactly. Shared origin. Plus, we even find meteorites on Earth that we know came from the moon.
Moon rocks just land here?
Yep. Asteroid impacts on the moon can blast lunar rocks into space, and some of those eventually fall to Earth. Yep. Studying these lunar meteorites also supports the impact theory.
So, in a weird way, the moon has collided with Earth before, just differently. It was part of its birth.
In a manner of speaking, yes. That ancient collision set the stage for the relationship we have now. Okay, let's get back to our less pleasant scenario. T minus 200 days.
Okay, where are we now?
The moon's much closer, only 100,000 kilometers away. Half the original distance gone.
Oh boy, what does that do?
The tidal forces become extreme, truly immense.
How extreme? We were at 5 meters before.
Now, think tidal surges potentially reaching up to 30 meters high. 30 meters. 30, that's insane. Coastal cities aren't just flooded, they're obliterated, completely uninhabitable. Any infrastructure, subways, tunnels, roads, buildings near the coast, gone, wiped out. Total devastation.
Why such a massive jump? Just the proximity?
It's the inverse square law of gravity, essentially. Gravity's pull gets much stronger as you get closer, so having the distance doesn't just double the tidal force, it increases it much more significantly. The pull is just enormously stronger.
It's like cranking the volume knob way past 11. Is there any evidence Earth had tides like this way back when?
There is. Geological records looking at very old coastal rock formations from billions of years ago.
When the moon was closer, right after it formed.
Exactly. Back then, the moon was much closer to Earth. And we find evidence in those ancient rocks of much, much higher tides than we experience today. These fossilized tidal patterns support the idea that the moon started close and has been moving away.
Which is the opposite of our nightmare scenario. I heard that the moon is actually moving away now, right? Slowly.
Yes, that's correct. It's currently receding from Earth at a rate of about 3.8 centimeters per year, about the speed your fingernails grow.
Why is it doing that? Did the big impact set that in motion too?
The giant impact hypothesis actually helps explain that too. The model suggests the moon formed very close. Since then, the gravitational interactions, the tides the moon raises on Earth, and the Earth raises on the moon cause a transfer of energy. Earth's rotation slows down slightly, and that energy gets transferred to the moon's orbit, pushing it further away.
So it's been drifting away for billions of years.
Pretty much. It's a very slow process, though.
That 3.8 centimeters a year, it doesn't really affect us day to day, does it?
Not over human timescales, no. You need millions of years for that gradual recession to make a noticeable difference to things like tide heights or day length. It's nothing like the rapid approach in our hypothetical.
Right. We're on the fast track to doom here. So, with 30-meter tides, where could you possibly be safe? Higher ground.
Relatively speaking, yes. Cities at significant elevation, think Denver, Calgary, Mexico City, places over 1,000 meters above sea level, they'd avoid the direct flooding, the inundation.
Okay, so head for the hills. But it's probably not that simple, is it? Being high up doesn't mean you're safe overall.
Definitely not. Escaping the floods is one thing, but as the moon gets even closer, a whole new set of global problems emerge.
Such as? let's push on. T-minus 100 days. We're really in the thick of it now. What's happening?
Okay, 100 days out. The gravitational stresses are intense across the whole planet. We'd likely see dramatic shifts in weather patterns globally.
More storms.
Yeah, I think much more frequent and much more violent. Hurricanes, typhoons, massive storm systems fueled by the disrupted atmosphere and oceans.
So, drown, get blown away.
What else? You mentioned geology earlier.
That becomes critical now. The moon's gravity is putting immense strain on Earth's crust and mantle. It's literally pulling and squeezing the planet.
Leading a massive increase in earthquakes and volcanic eruptions. Not just more frequent, but likely much more powerful too, all over the globe.
That ring of fire zone must be just constantly erupting.
It would be incredibly vulnerable, yes. Given that it already accounts for most of Earth's volcanic and seismic activity, the added stress would almost certainly trigger widespread catastrophic eruptions and quakes there.
So the places that were safe on high ground, now they're dealing with earthquakes shaking cities apart and volcanoes burying them in ash.
Exactly. It becomes a truly global cataclysm. There's really no safe haven.
It sounds utterly hopeless. Is there anything we could even theoretically do? Could we, push the moon away?
It's a natural thought. We do have some experience nudging celestial objects.
Yeah.
NASA's DART mission is the prime example.
Right, the double asteroid redirection test. They hit an asteroid with a spacecraft.
They did, back in 2022, and they successfully changed its orbit slightly. It proved the concept of a kinetic impactor, basically, hitting something to move it.
So could we do that to the moon? Build a giant dart?
The scale difference is astronomical. The moon is vastly, vastly more massive than the small asteroid DART targeted. The amount of energy required to alter the moon's trajectory in any meaningful way, especially on a short time scale like this, it's almost unimaginable, far beyond anything we could currently engineer or power.
So a technological Hail Mary is probably out.
Highly speculative at best.
Yeah.
The DART mission shows the principle works for small bodies, but scaling it up to the moon, that's a whole different league. Plus, there might be another factor.
What's that?
Something called the Roche limit.
Roche limit. Okay, what is that? Does it save us?
Not exactly save. The Roche limit is the distance from a celestial body, like Earth, within which a second body, like the moon, held together only by its own gravity, will actually disintegrate.
Disintegrate. Why?
Because the tidal forces from the first body, Earth, in this case, become stronger than the second body's own self-gravity holding it together. Earth's gravity essentially pulls the near side of the moon so much harder than the far side that it overcomes the moon's internal gravity and rips it apart.
So, instead of one big impact.
Correct. As the moon gets really close, probably around 18,000 kilometers or so for our moon.
That's really close.
Extremely close. Earth's gravity would just shred it. The moon would rupture, break into countless pieces.
Pieces ranging from
Dust and pebbles up to large asteroid-sized chunks of rock.
So no final collision thud, but a catastrophic breakup. What happens to all those pieces?
They wouldn't all just rain down immediately. Most would likely continue orbiting Earth, spreading out over time.
Forming, like rings, like Saturn.
Exactly. We could end up with a spectacular ring system around Earth, made from the fragmented remains of our moon.
Wow, a ring of moon debris. That sounds simultaneously beautiful and utterly terrifying.
Visually, it might be stunning, but the consequences would be dire.
How so? What would a ring do?
Well, first you'd have constant, intense meteor showers, debris raining down through the atmosphere. Many small bits would burn up, but larger chunks would definitely reach the surface.
So frequent impacts. Great.
A persistent threat, yes. And then there's the sunlight issue.
The ring would block the sun.
Parts of it, yes. Depending on the ring's density and orientation, it would cast shadows, reducing the amount of sunlight reaching the surface.
Which affects plants, photosynthesis.
Precisely. Plants and phytoplankton, the base of most food chains, need sunlight. Less sunlight means less photosynthesis, which means less food, and less oxygen being produced.
Less oxygen on top of impacts and floods and volcanoes.
It adds another layer of stress for any potential survivors. Yes. Breathing could become more difficult over time.
And less sunlight must mean it gets colder.
Very likely. Significant global cooling. There's actually some geological evidence suggesting something like this might have happened before. About 450 million years ago, a large asteroid may have broken up near Earth, creating a temporary debris ring.
And what did that do?
Some studies suggest it correlated with a significant ice age, potentially dropping global temperatures by as much as 8 degrees Celsius.
An 8-degree drop globally? That's massive. That would finish off agriculture, surely.
It would be devastating for any remaining food supplies, absolutely. extreme temperature shifts making large-scale farming impossible.
And all that debris flying around.
Right.
What about our technology? Satellites.
Obliterated.
Hmm.
Communication satellites, GPS, weather satellites, they'd be destroyed by collisions with the ring debris pretty quickly.
Yeah.
Global communication would likely collapse.
And could we even leave? Could we escape into space?
Extremely difficult, if not impossible. The ring itself would be a hazardous debris field, a barrier making space travel incredibly dangerous. We'd essentially be trapped on a rapidly cooling, bombarded planet.
So whether it hits us directly or gets torn apart into a ring, the outlook is bleak. Widespread death seems almost certain.
The probability of mass extinction would be incredibly high, yes.
What about long term, decades, centuries later? Does the ring stay forever?
It's uncertain how stable it would be or how long it would take to form properly. Initially, it might be a chaotic mess of debris in various orbits.
Not a neat flat ring right away?
Probably not. It could take tens, maybe even hundreds of thousands of years for gravitational interactions to sort it into a more stable equatorial ring system.
That's a long time to be living under a cosmic construction site, and the environmental effects would last.
Oh, absolutely. The altered sunlight, the potential for a prolonged ice age due to that and atmospheric changes. It would create immense challenges for any ecosystems that managed to survive the initial cataclysm.
Okay, so let's just recap the horror. Two main worst-case paths. A quick, fiery impact if it doesn't break up, or this slower approach where it gets shredded by gravity, forming a deadly, climate-wrecking ring.
Neither is appealing, but the ring scenario, while visually striking, brings its own prolonged set of devastating consequences.
Yeah, that image of a ring made of moon chunks is powerful, but living with constant meteor strikes and freezing temperatures, not so great. It does make you think about survival, though, those doomsday bunker scenarios. If you actually had one and could only save a few people, who do you choose? What skills do you prioritize? It's a horrible thought experiment in itself.
It really underscores the impossible choices that such an extreme event would force upon anyone left.
So here's something to chew on for you listening. Faced with this, would you prefer the quick, unavoidable end of a direct impact, or the long, drawn-out struggle for survival under a deadly, albeit maybe beautiful, lunar ring with only the slimmest chance?
It's a grim choice, isn't it?
Right.
It really throws into sharp relief how fortunate we are with the current stability of our celestial neighborhood.
Definitely. And let's be absolutely clear. The good news here is that this whole scenario is virtually impossible.
Right. As we discussed, the moon is actually moving away from us, very slowly. Its orbit is stable. Earth's gravity has it locked in.
We are safe from a lunar collision. You can sleep soundly tonight.
The laws of physics are on our side for this one.
Still, it does get the mind racing about other what-ifs, doesn't it? Like, what if it wasn't the moon? What if, say, Mars decided to pay us a close visit?
Well, that would be a whole different kind of problem.
Indeed. But that perhaps is a deep dive for another time.